Hey everyone, it's Mr. Canfield. Today we're starting actually geometry. So here is our first activity, match mine. Geometric figures are made up of points, lines, rays, and segments. We use symbols as a shorthand for writing and describing these decomposed parts. In today's activity, you'll be matching geometric figures with their symbols. So, boom, look at all these symbols. You're gonna get these in cards if you were in class, but if you're not in class and you're watching this video, here you go. So, each of these is represented here. So, kind of spoils it, but so this one, this is the congruency symbol. That means that two things are equal to each other. So, let's see, we need two things that are exactly equal. Those are parallel, that's not equal because it goes, oh look, these are both 5.2. So we could say AB is congruent to DE. And they've got the little thingies over top to represent a segment. So let's see, we need AB, and this one just goes pew, it just goes the one way. Wonder if that's any of them. Oh look, here's one, it goes A to B. So AB, pew. Would this one be AB? No, this one starts at B and goes to goes to A, so we can call this one BA. Pew. You'd also call it BC. But in here, BA is that guy. So let's see, what else do we have? Well, we have AB and it's going in both directions, so that would be this one. So AB going in both directions, pew pew. This little arrow means that they're parallel to each other, so, and these are both lines, so that gives us this AB and DE thing. AB, DE, they go pew pew, pew pew, pew pew, pew pew, and then pew pew. Sorry for the sound effects, I can't help it. Let's see, you could call this B, oh, but it's got the thingy on it. We don't want the thingy. Oh, let's use this one, right? This is just from A to B with a little boop. So you'll notice all of these have lines over them except for this one. And that's because when we don't put the thingies over top, technical term, when we don't put the little lines and the line segments and the rays and stuff over top, these are considered measurements. And so the measurement of BA plus the measurement of AC is the measurement of BC. Well, only a couple of these have actual measurements on them. And if you look here, BA plus AC is the whole thing, is BC. So that one is this one. And again, this is something that we are going to do in class as like an activity, so this is kind of ruining that. Let's see. We have a right angle. Do I see anything that looks like a right angle? This is the perpendicular symbol. So we can say AB is perpendicular to DE. And I should put the line segment. All right, you can be very technical with these markings. A lot of times you can basically communicate what you're trying to say without being super technical, but it's better to be technical. All right, so then down here we have BE and CA have these little marks on them. Those are congruency markings. So that tells us BE and CA are the same. So we can say BE line segment is congruent to CA line segment. So what do you think each of the following symbols means? Well, I'm gonna tell you, this means cake. Wait, no, it just looks like cake. It means congruent, which is equals, basically equals, or same. Just a reminder, when you do your own notes, you don't need to copy everything I'm writing. The whole point of notes is for you to put what's in your brain on the paper. So if this was something you've seen a billion times and you already knew what it was, there's no need to write anything there. But if there was anything new that you picked up and you were like, oh, I didn't realize that the word for that was congruent, then you might want to write that. Or, oh, I didn't really realize that this is just equals. Or I didn't realize that upside down T was perpendicular. Or maybe you forgot or didn't realize that perpendicular means 90-degree angle, must mean 90-degree angle. And then maybe you didn't know that these are parallel. You know, or maybe something as simple as I didn't know that parallel had two L's in the middle, and you can write that down. So then let's see what's our next one. Think about the notation we use for segments, rays, and lines. For which of these does the order of the points matter? Is AB the same as BA? Why? So let's look at these. Which ones of these does the order matter? Now, I've already kind of spoiled it a little bit. On these two, the order absolutely mattered because there's a definite start point and then it goes forever. So I couldn't call this ray CA because it doesn't start at C and then go forever. It starts at A. So for lines and segments, the order doesn't matter, but mainly rays, because there's a start, woo, and then forever. So if you want to write a sentence to go with that, the way that our notes talks about it, or the way that the people who make this talk about it, for lines and segments, the order doesn't matter because they have no direction. For rays, the order matters. So you always, pause the video and write that down if that's something that you want. And nothing fell on the floor. Everything's fine. All right, let's do our quick notes. If I spoiled it for you by showing that I have the answer key printed out, no, I memorized everything. All right, so if we have something called a point, so the point A, we would go dot with a little a on it. That's how we're going to draw it. Then we have segment AB. That's going to be AB with a line over it, and it's going to be dot, dot, wee, A to B. Then we have ray AB. That's AB with our arrow like that. It starts at A. Here's B, and it goes, pew, goes forever, but it passes through. It starts at A, passes through B, and then goes forever. Line AB. We have AB, and we have, remember that's the segment, and then we put the arrows to show it goes both ways forever. So here's A, here's B. Woo, I missed. Maybe I should draw my line first and then put the points on it. All right, and then just in case you missed it from before, that's parallel. It's got the double L just like the word parallel has double L. Boom, that's perpendicular. I usually just write perp because it saves time. Cake is congruent. Only segments have length. If I'm writing in all caps, I should keep writing in all caps. So here's one extra note. Here's our second extra note. To bisect means to cut in half. Bisect two sections. So draw the following geometric figures. Let's see if you understand. You should pause the video and see if you can do these. All right, here we go. Ray AB, because it's got a dot and then goes forever. Whee! So here's A, here's B. I know it's like right up there, but just BD is equal to AC. All right, these are segments, so it doesn't matter if you write them in exactly that order, but BD, AC, I feel like those don't look the same, but you draw that congruency marking on there, they are the same. That's what that marking is used for. It's to correct for any errors in our drawing. All right, AD and AE, what kind of, well, AD is a line that goes forever because it's got the arrows on both ends. So I'll do this. Here's AD. Oh, and then AE is a ray that comes off of it. So I gotta start at A and make a ray. And it says they're perpendicular, so I'm gonna be like, bop, and then draw that little right angle. So I could have, oh wait, I gotta write E somewhere. Here's E. So AE could have gone up this way. It also could have come down this way. I had options with how I drew that. Okay, name at least 2 rays, segments, and lines in the figure below. Clearly identify them in the figure. Let's see, segments. Let's see, I got a segment between C and F, between F and B, between F and D, between DG, A, F, A, B. Like there's so many, CE, there's so many segments. You label whatever you want. I'll say C. Ooh, I'm gonna say CD for fun because I can. There's a segment CD. Boom to boom. And then I can say segment AF. Boom, boom, segment, cool. So now let's say 2 rays. Let's see, well, a ray starts and then goes. So, oh, you know, I said segment CD. I could also say ray CD if I wanted to. And I could also do ray CF. It's the same as ray CD. I could do ray FB. And with that, you know, we've got some lines here too. C is not on a line though. C is on a ray here or some segments. But DG I could say is a line, or GD. So DG is a line. Let's see. This one goes forever. Yeah, I'll say line AF as well. So line segment AF and line AF are different. Like line AF here, segment AF. Point B is not on segment AF, but point B is on line AF. Let's see, which of the following are impossible? Let's see, A, B, and D, E are equal to each other. A, B, D, E. Wait a minute. These have arrows on the ends. Lines don't have length. Only segments have length. So they can't be congruent. Yeah, that's not a proper sentence. Lines don't have length, comma, so they can't be congruent. Line AB bisecting segment CD. Line AB bisecting segment CD. So does this line come through and cut this in half? Is it possible? Yeah, it's definitely possible. So I'm realizing now they're probably not actually referring to this figure. They're just referring in general. So like if we have segment C and segment CD like this, well, we can have a line come through like that, call it AB. Oops, that's not what I meant to draw. We don't care about the angle that it's bisecting at. We care that it's bisecting. So like, here's the halfway point. There's a line. Those are the same. So this is line AB. All right, let's see. FG bisecting the ray DE. Wait, hold on. A ray. Can you cut a ray in half? So it goes forever. Where's half of here to forever? No, not possible. So can't cut forever in half, bro. All right, a pentagon created by 5 rays. So let's see if I can draw this. Here's a ray, goes. I'll put a dot on that one, goes. I'll put a dot on that one, goes. I'll put a dot there, goes, and I'll put a dot there, goes. Smiley. So the impossible ones were A and C. All right, now let's do some numbers. AD's 15. All right, I like to draw on these when I do them. 15. BE is 7. Okay, 7. CB is equal to 3 DB. What's up?
Mr. Seferson, we appreciate it and thank you so much for letting us use this.
Of course.
Yes.
Not refilming. That was tally. All right, let's see. So CB is equal to 3 DB. I feel like I'm missing something. Oh, AC is equal to DB. All right, so let's say AC is equal to DB. Okay. Oh, so CB here, this whole thing is equal to 3 of these. And this is equal to that. So that means that this right here, since these are the same, well, if this whole thing is 15 and we know that this is 3 times the length, well, we know that this is 15 too. So that's 15 and that's 15. We know that this is a third of the whole thing. Well, then this has to be 5, and this would be 10. That'd be 5. Oh, I want to find DE. Well, DE is just from D to E, so that's 5 plus 7. 12. All right. So if you flip it over, you'll go back to the first part of the page that you were on. I'm so funny. I hope this was helpful. And maybe I'll even do some going over the homework in a little bit. We'll stop it there. Have a great day. Bye.